Welcome back. We're continuing our study of the history of software-defined networks. In this lesson, we'll talk about the history of active networks. We will talk about what active networks are, the motivation for active networks, and the technology that supports active networks. We'll also talk about how active networks relate to software-defined networks, as well as the legacy of active networks for SDN. To remind you where we are in this module, we just completed a lesson on the history of central network control, which dates back at least to the 1980s and AT&T's network control point. We're now going to study the origins of network programmability, in particular its roots in the active networks projects of the 1990s. So first of all, what are active networks? Simply put, active networks are networks where the switches perform custom computations on packets as the packets travel through those switches. Some examples. You might imagine a router or every router in the network performing some kind of tracing or a program on the packets as they travel through the routers. Middle boxes are also an example of active networks. Boxes in the network that perform firewalling function, proxying, application services, and so forth are all custom computations on traffic that are performed in the network. And we can think of middle boxes as a modern-day form of active networks. Where did active networks come from? Well, in the mid-1990s, the DARPA research community was discussing various problems that existed in today's networks. In particular, they identified that it was very difficult to integrate new technology into the network, and that sometimes the network would exhibit poor performance because the same operations were being re-implemented at multiple layers of the protocol stack. Finally, it was noted that it was difficult to accommodate new services as they're introduced into the network. So in a nutshell, the motivation for active networks was to accelerate innovation. It was observed that innovation relies on consensus, and that from the time at which a working prototype was demonstrated to the time at which that technology would ultimately be deployed in an operational network could take as long as 10 years because of standardization, the process of procuring new hardware, and ultimately testing and deploying it in a production network could just take forever. If that motivation sounds familiar, it's because SDN actually has the same motivation. That is, accelerating innovation in existing networks so that technology could be introduced a lot more rapidly without consensus, standardization, etc. Well, active networks had the same motivation and observed that if you could put active nodes in the network where routers could download new services into the infrastructure, that could allow for some user-driven innovation. So the main idea here is that messages or packets would carry both the data and procedures that might operate on that data. So these active routers that perform these custom operations might coexist with legacy routers that do nothing more than forward the traffic. Each of these programmable switches might then perform additional processing in addition to forwarding the traffic. So there were both user demands and technology enablers that made active networks compelling at the time. On one side of the coin, the demand side, the proliferation of firewalls, proxies, transcoders, etc. resulted in a lot of ad hoc point solutions to solving various custom packet processing problems. And the goal or the vision of active networks was to replace a lot of these ad hoc approaches with a more unified approach. On the flip side, we had technology push or enablers. There was a lot of research and technology being developed at the time in support of safe execution of mobile code. In particular, Java applets were emerging, and those provided the ability to develop portable code that could run in one place or another, and it allowed shipping code around, which was a very natural supporting technology for certain types of active networks. Also, various operating system support was being developed. The Scout operating system focused on support for real-time communications. The exokernel developed new technologies to allow safe access to low-level resources, and Spin focused on providing trustworthy code or providing technologies that could enable generation of the trustworthy code. So there are two different approaches to active networks. The first was a rather extreme approach, and that was essentially that every message or every packet actually carried a program. And active nodes along the network path would evaluate that code that was being carried in the packet. So the code, as it was carried in the packet, would be dispatched into an execution environment that was running on a programmable switch or router. We'll take a look at capsules in a little bit more detail on the next slide. But the other approach was something that looks a lot more familiar to us now and almost looks like SDN. And the idea here is that you can have programmable switches where code would be installed. Those programmable switches then would perform custom operations or processing functions on packets depending on values in the packet header field. So essentially, packets would be dispatched to the appropriate code block depending on the values of packet headers. So that sounds a lot like SDN. You wouldn't be mistaken. Let's just take a quick look at capsules. So capsules essentially expand the existing packet header. So in addition to having the regular IP header with your payload, you would have an active networking header. And this particular one was the ANTS header. This was developed at MIT. And this header actually had a few additional fields. One was the type, which specified the forwarding routine to be executed, in particular code by reference. The previous address basically told the node where to obtain the forwarding routine if it wasn't available on the present node. The dependent fields allowed the packet to pass parameters into this code. And then, of course, there was the payload itself. So some previous notable projects in active networks. One was the ANTS project, which we just referred to, and that actually took the packet capsule approach, where Java programs would actually be carried with these packets. Naturally, this introduced some limitations for guaranteeing quality of service, and in response to that, the University of Arizona had implemented something called the JAWS JVM, which provided better real-time performance for active network scenarios. There was also the Switchware program at Penn, which developed a programmable switch and a scripting language that could support the invocation of switchlets. The Smart Packets project at BBN focused on applying active networks to network management problems. Open Signaling at Columbia developed a language called NetScript, which allowed a programmer to specify custom packet processing routines and pipelines on streams of packets. We will look at some more modern programmable data planes later on in this course that look a lot like Open Signaling. Finally, there was the Tempest project at Cambridge, which invented something called switchlets, which was a programmable, virtualizable switch, and we'll look a little bit more about at that in the next lesson. So what happened to active networks? This technology was introduced almost 20 years ago. Why didn't we see some of these ideas come to fruition sooner? Well, for one, the timing was off. At the time, there was no clear application for this type of programmability. As we've seen now, and as we'll see throughout this course, one of the killer apps or killer environments for SDN was the data center and the cloud. And at the time, the data center and cloud just didn't exist. So there was no particularly clear application for active networks, at least no immediate application. Additionally, hardware support wasn't cheap. Everyone was using ASICs to support this type of technology. Now we have a lot more options to support programmable data planes, such as TCAMs, FPGAs, and network processors. There were also some missteps. In particular, there was a lot of focus on security, providing special languages for safe code, talking about packets that carry code, etc., and maybe too much focus on this as opposed to the general concept or the overall goal of how do we provide programmability in the network. So whether or not it's done by a capsule or whether or not it's done by a programmable switch was less important than simply providing that programmability or flexibility in the infrastructure. There was also potentially too much focus on the end user, people like you and me sitting at our laptops or end user devices in our homes as the programmer. In contrast, SDN has now focused on the network operator as the programmer, or the application service operator, people who actually want to introduce new technology into the network. Finally, there was a lot of focus on interoperability between existing active network implementations and deployments. And in contrast to that, OpenFlow essentially punted that. They did a very good job with grappling with backwards compatibility in existing switch hardware. It was it's effectively a simple firmware upgrade to provide OpenFlow support into existing switches, and many switch hardware platforms already support these basic operations that OpenFlow specifies. So let's just think about the legacy of active networks for SDN for just a minute. What lessons can we take away from active networks? Well, the first was the idea of providing programmable functions in the network to enable innovation. That problem statement, or that motivation, is almost identical to the SDN motivation, and it has roots in active networks. The second was that idea, the programmable switch approach, where switches would actually carry code, or code could be installed on switches, and then the packets or values in the packet headers would determine how those packets would be demultiplexed into the correct code block. That idea actually came from active networks, and we've seen it over and over and over again in projects like PlanetLab, FlowVisor, Genie, even now all the work talking about how to integrate SDN with middle boxes. It all has roots back into this idea that came from active networks. Finally, just one more point on middle boxes. It's worth noting that active networks paid a lot of attention to middle boxes. One of the motivations for active networks was the proliferation of different kinds of middle boxes and the vision for a unifying architecture. So we're now seeing the same type of vision being espoused in various SDN projects, and it's probably worth going back to look at some of the work on active networks to see whether or not some of the same lessons that were learned there could be applied to integration of middle boxes with SDN.